a region familiar to us, bounded by the graphs of this equation and these two lines. This time, let's revolve about the line x equals -1 and use the cylindrical shell method. And using the cylindrical shell method, my rectangle is vertical. It would have been horizontal if I used a washer method. Now, revolving about that line, x equals -1. Well, yet again, here's my schematic. 2 times pi times the radius times the height times the thickness of that cylindrical shell. Now, let's see. The radius is going to be this x value minus this one. Now, because the thickness is going to be a small change in the x direction, I want everything in terms of x. So the radius is going to be this x value, the large one, minus the small x value. So x minus -1. Now, the height of the cylindrical shell is this y value minus this one. But the y value downstairs has to be described in terms of x. And the y value is described as such in terms of x. And lastly, just over the shaded region that was indeed being revolved about that line, whose equations here, is ranging from one extreme x value to another. Well, here's one extreme x value, here's the other. Now, I have to confess, there is a slight problem here in that we have not discussed how to actually evaluate the integral involving a factor of x as well as that exponential factor, but that's coming up very, very soon. For now, I'm merely left to setting up the integral.